Yeah, that looks good.
Awesome. All right, let's get started. So yeah, thank you everyone for coming. Really excited to come teach you guys about blockchain, Ethereum, Solidity, and we're going to talk about Scaffold-ETH today. So a little bit about myself. My name is Kevin, aka Shutterblock.eth. That's my ENS name. I am an advocate for Scaffold-ETH, so I do a lot of public speaking events trying to promote Scaffold-ETH. It's basically a toolkit that allows you to prototype and build decentralized applications really quickly and kind of build out applications and kind of get up and running quick. It's got everything you need to basically do that. Hard hat, React, it uses Ethers.js, and we're going to actually show that a little bit later. I'm at the Build Guild, which is basically a kind of a community of developers and advocates where we kind of like promote public goods and try to bring more developers into the Ethereum space. This is pretty much all my contact info. So if you guys take a picture with your phone, it should pop up the website for my hi hello. You guys can add me as a contact. You'll have my Twitter, my GitHub, all that good stuff. I'm also going to start a YouTube channel, so that's there. So if you guys want to learn more about Web3 and stuff like that, please follow along. So really quickly, just a little bit about Growic. Growic is on a mission to make higher education collegeless, admissionless, and tuitionless, basically for everyone. And it's basically an alternative to be able to provide new skills, get promotions, land new jobs, grow your own startup. And it's really just an idea of free education. And it's really exciting to be a part of this because I think that's kind of what we need is more focus on education. And I think this is a great example of how you can kind of get involved in a community and learn from other people in that community. And Web3 is a real good place to do that. So this is part of the Solidity Developer Career Track, which is really to get you everything that you need to know to be able to be a Solidity developer and either land a job or run your own startup. It's important to know that it is a pilot program. So this is the first time that we're ever doing this program. And we are really, really looking for a lot of feedback. So you can go onto the Discord channel. If you guys aren't on Discord, please pop on there. The Discord server is really quite useful. It's got all the different channels for each of the sessions. And there's a feedback session, or I should say a feedback channel here that you guys can provide any feedback to. And then there's a separate channel, like I said, for every session. So you can see this channel session for this one is here, and I'll be posting some follow-up stuff in here, like the slides and a little bit of a recap. But overall, please use Discord and provide some feedback and let us know how we can make this a better program for you guys. It's really like I said before, it's a chance for you to bring Web2 developers into the Web3 ecosystem, or just teach people that want to get involved and learn about Web3 and land a job or build their own startup. The idea is that by the end of this, you will have some projects that you could actually have under your belt that you can actually publish to your GitHub, and people can kind of see the work that you've done and show like how you might know how to build a dApp or work in Solidity. And so the idea is that you'll be able to have something to show by the end of this, and you'll be a full-blown Solidity developer. Everything's online, of course, and each topic is around 3 days, give or take on the subject content. Some people might learn it a little faster, some people might take a little longer, and so this is also something we're looking for feedback on. We'd like to know, did we have enough time to do this? Was the session long enough that you learned the content? So again, this is another thing that we're looking for feedback on. And just, be as interactive as possible. Get on the Discord channel and talk to us. This is the link for the Discord channel if you guys don't have it already. Feel free to snap a shot of that. All right, so let's get started. So the goal for me for today is is really to go through probably like half of the time is like some slides, and I'm going to be like trying to basically give you guys a lot of information about crypto and Ethereum and blockchain and kind of get you guys' brain moving a little bit. I don't expect you guys to be able to remember everything that I tell you guys today, but it's really to give you guys like kind of this high level overview. I'm going to dive in a little bit deep on some stuff, but really we're going to kind of start high We're going to talk a little bit about why Web3 is like so important and what it kind of promises for applications. We're going to dive in. We're going to go a little bit deeper on some things. I don't expect you guys to soak in everything, but it is really just to kind of like give you guys at least a foundation of kind of what building on Ethereum and building on Web3 really is all about. But the goal is to land you guys on your feet, right? After you guys are done with today, get you started being able to go through this entire course and really kind of take off from here from a solidity development standpoint. So the first question is, why build on Web3? Isn't Web 2 like good enough? So, personally, the reason that I got into Web3 is I was really interested in kind of some of the problems that Web3 aimed to solve. But without kind of understanding what those problems are, you have to kind of think about like where we actually came from the internet. And I like to always kind of like level set on this. I got started with the Web 1.0, right? The very first concept of the web was it was static content, right? Information was being broadcasted from a file system, whether it's someone's computer that they were running a web server on. But everything was very simple. It was simple static websites, simple static HTML. Maybe there was some JavaScript, but really everything was about the static web. Everything was running pretty much on bare metal servers at the time. Virtualization was not much of a thing. And everything was really simple, right? You went to a website, you got what you needed, you logged off. There was no kind of complex interactions with the website. Web 2.0 came along and kind of like completely changed the game, right? Everything became about infrastructure. The infrastructure expanded. The concept of distributed systems was adopted and widely adopted. This idea of applications not only being hosted on bare metal servers, but on cloud providers, on virtual machines, hosted inside of containers. And then sites got a lot more complex. It wasn't just about going on and, and at this point, it was more about the user, and information was flowing between that user and the provider of the site or the site you were using. And we got the birth of new protocols. It wasn't just about HTTP. Then it started to get about TCP and UDP, and APIs were built, right? And it was applications were talking to each other through API calls, databases. You can see everything got more complex, but it also provided a lot more utility. The idea that you could do business to business type related things. You could do more social media, blogging, Facebook, all of the social media giants that we see today. And it really was the data-driven web, right? But then Web 3, kind of this new concept came around, and it was like a complete change in the way that we thought about building applications. And the idea was everything should be decentralized. The idea of blockchain technologies came to fruition, and the idea was that users could interact with a dApp or a distributed application that was also destroyed not destroyed, but deployed in a decentralized way. And these dApps or maybe providers could connect to nodes on a decentralized network, and users that wanted to interact with the dApp could do so using cryptography, right? Which are basically applications that host private and public keys, or called wallets. And the idea is that all of the application logic is stored in what are called smart contracts. So as opposed to running a server and having an application server running, you have this smart contract where the smart contract is the law, and the smart contract is what governs the application and how it operates. And it can essentially run in an immutable way where you can deploy a smart contract. And if you deploy the smart contract correctly, the smart contract could technically live forever as this kind of application in a decentralized network. All the changes to state are then stored on a public ledger. And that concept is that everyone can see it, it's transparent, it's immutable, and it's decentralized. And it's this whole new kind of concept of thinking, right? And also the digital economy of this token-based digital economy, I should say, really drives the incentive for network security and for growth. right? The more people that adopt the network and the more people that secure the network with whatever consensus, which I'm going to talk about later, algorithm to secure the network, makes it stronger and more valuable, right? So everyone contributing and everyone building on the protocol essentially extends the power and the functionality of that decentralization. And the other concept is digital sovereignty. You get to reclaim your data, right? The data is yours in the sense it's not owned by one particular intermediary. I talked earlier just about dApps or providers. I just want to make a note about that. A dApp is like an application that you might have deployed, and we're going to get into what that looks like. And providers are some of these third-party providers that provide like APIs that give access into the blockchain, or they provide like an SDK, or they might provide like a node as a service. And so the idea is that either the providers or the dApps directly can communicate with nodes. If you have a dApp that you've deployed, you might also have deployed a node, and you kind of run and manage that node, or you might pay a provider to manage the node for you. Don't need to know too much about that, but that's just to kind of give you guys a level set on kind of what that looks like. So what does it look like from the developer standpoint? A developer writes their application and their dApp, and they write it in something. Some of the most popular usually is in JavaScript. So there's a lot of developers that use React or Next. We're going to be talking a lot about React in this course because that's what Scaffold-ETH is built on. And I'd say it's probably the most popular. And everything is deployed on a distributed file system or an IPFS usually. So the idea is that you build your application as this kind of like static site that doesn't require on anything more than just the static resources, and you deploy those assets on like something like IPFS. So the IPFS is the interplanetary file system. And I'm going to talk about that after this slide, but it's essentially just a decentralized file system that allows you to distribute content as hashes as opposed to a physical data storage. And then from a smart contract perspective, developers can create smart contracts, which are they're basically applications that have code that is stored on the public ledger, and it's verified by what's called blocks. And that's what the blockchain essentially is. It's a verified block or a set of verified blocks. And we're going to talk about what that means a little bit more. But everything is self-executing, and all the logic is handled inside the confines of that smart contract. So the smart contract is literally distributed amongst the entire cluster. And again, this removes the need for any like central authority or intermediary. Users can interact with the blockchain by just using their wallet and make interactions with it. And really this provides also another way for these smart contracts to act as banks. So they can actually store value in the form of Ether or some other kind of token, which allows them to act as a bank or to act as this kind of central intermediary. That's where you see the concept of like DeFi or vaults, right? Like something like Gnosis Safe, which is like a vault for storing value. Most of the smart contracts are written in a specialized language called Solidity, or something, there's another one called Viper. Everything we're going to talk about, of course, is Solidity. It's probably the most popular smart contract language. And it's really a good, easy, low-level language, and we're going to talk a little bit about that. And these dApps that you write in JavaScript react with, or I should say interact with your application or the smart contract using a SDK. So there's Web3.js, there's also Ethers.js. Scaffold-ETH uses Ethers.js, which is I think it's probably the most powerful way for you to interact over JavaScript with the blockchain. Or you might have like a provider like Moralis. You've probably heard of Moralis, or some other kind of like provider that provides an API for the blockchain as well. There's also one for data called The Graph, which allows you to have an API data endpoint for your application. So there's all these like providers that provide APIs. We're not going to get too much into that in this course. Really everything that we're going to be focusing on is the Ethers.js interaction, the smart contract, and learning to write smart contract. And you're going to communicate with a provider on pretty much everything you guys do, which is called Infura. So you guys won't need to run your own node or anything like that. You'll use a provider that has a default interaction with Scaffold-ETH. So again, as users use your dApp, blocks are built on the ledger, and that's how the blockchain is built, right? One user might connect with their wallet, make a transaction, and then a new block is formed. And we're going to show how that works a little later too. A note about IPFS: if you are a developer and you want to build your app in a truly Web3 decentralized way, you would use a distributed file system, or you use the interplanetary file system. Most of the stuff we're going to be doing is going to be using either locally running React. So we're not really going to deploy our app, especially today. We're not going to do any of that. But it's good to know about it, because IPFS is kind of the most common way that people deploy their application in a decentralized way. Scaffold-ETH uses what's called Surge, but it's kind of a similar concept. Surge is more of like a web service that hosts applications. This is a truly decentralized technology. And the concept is you push data to the IPFS network and you get back a unique hash. It's basically like a string that points to where that content. So it's actually a hash-driven searchable place. So you can actually store your content as a hash and not as a location. So as you push the data to the network, it's distributed evenly on the network. Again, you don't need to know too much about this, but I do want to kind of just give you guys an understanding of what it is. And then if someone comes in and wants to get access to that content, which if they're using your dApp, they're probably going to get pointed there at some point to IPFS. They're going to use the HTTP gateway to gain access to that data. And the IPFS network is smart enough to know, based off the hash, where the content sits in the network. So it's just really truly a way of not having to rely on like services like AWS or whatever provider, Google Cloud or whatever you're using to host your web application. You literally just host it on the IPFS, or you host it on like a IPFS pinning service. There's lots of them. There's like Fleek, and there's all these different providers that provide IPFS as a service. And this concept is you don't need to have a central server. It's all distributed. So a note about Solidity. So Solidity, again, it's a very simple kind of low-level language. It's object-oriented. I should say, I'm sorry, it is a high-level language, but when you compile your code, it gets compiled into a low-level language, or it's called bytecode actually, and I'm going to show what that looks like. But it's a very easy to read. It's statically typed. It uses curly braces, so it kind of represents and kind of an easy to read language. Looks very similar to like Python or JavaScript, kind of mashed together. Optimization is very important with Solidity, because everything that you do on the Ethereum network utilizes what's called gas, and the more processing that you need to do inside of your smart contract, the more expensive it can be to run that smart contract. So it's very important that when you're going through the courses, that you learn to do things the most optimized way. And for the most part, all of the curriculum should kind of teach you that. But it's important to note that, again, it's the idea is that you want to try to write as little amount or do things in as little amount of steps as possible to really achieve the best code. And again, when you compile, you have your source code, which is written in Solidity, and these are SOL files. And as you compile them down, they get compiled down into what's called bytecode. And in order to read that bytecode, you need what's called an ABI, which is Application Binary Interface. Again, you don't need to know too much about that right now, because the tool that you're gonna be growing on or building on is really gonna do a lot of this work for you. But it is good to know these kind of these concepts. So this is kind of like just an example of what it would look like if you had your source code on the left. You have here, which is Pragma Solidity, and then the version of Solidity. So Pragma is kind of like, what version of Solidity should I use when I run this smart contract, so that the blockchain can have a backwards compatibility, right? Like any language. And then you have what's called a contract, and the contract is the smart contract that holds the entire application. And then you can define variables in there. You can have a constructor that is executed only at the time the contract is actually deployed. You can have a function that does a specific, computation, or maybe it accepts variables, maybe it returns variables. It's just like any other language. But when you compile it down, it gets compiled down into bytecode, which is this kind of like unreadable language. And how that looks inside of Ethereum is that that bytecode is actually translated and read as assembly. So the core of the EVM, the Ethereum virtual machine, actually runs on opcodes, or assembly language. So this kind of shows you, this is actually a real use case of what it would look like if you were to like try to dissect the contract. Again, this might be too complicated. You don't need to understand, but it is a good level set for you to understand what's kind of happening inside of Ethereum. So if you're a developer, you write your source code, you compile it down into bytecode, you create an ABI so that you're able to understand, and the tooling around Scaffold-ETH and Hard Hat, and there's a lot of different tools that do this, automatically create an ABI for you based on your smart contract. You push it to the network and deploy it. And then when you want to have your distributed application or your console interact with that code, it does so using the ABI. So the ABI is kind of like the map, right? The map to your application. So it's good to understand that you need that map, and it is generated at the compile time. And the cool thing about Scaffold-ETH, again, is it compiles it for you and it automatically injects it for you into your application. So you don't really need to understand kind of how to write your own or kind of how to read your own. It's just going to automatically do that for you. Okay, so I talked a little bit about how the network runs, and you have this concept of like validating blocks for the blockchain. So what does that mean exactly? Well, consensus is the idea of all of the nodes in the network need to come to an agreement, right? They need to know that these specific set of transactions are valid, and they do so by using a consensus algorithm. Okay, so the most common way, and the way that Ethereum runs, or Bitcoin, is using what's called proof of work. So if you don't know the concept, the idea is that if we look all the way on the top left, you see a transaction maybe comes through on the network, right? So if I'm interacting with a dApp and I want to use my wallet and maybe I want to send some money to Alice, I would make a transaction on the network and I would propose that transaction to the network. And the miners would pick up those transactions into a new block, and they would try to solve this kind of like puzzle, basically. It's basically like a calculation, and I'm going to show you what it looks like. And it's called proof of work, is the concept of trying to solve the puzzle. And they would broadcast it the minute that the first miners that got the successful puzzle answer, they would broadcast it, and all the other miners would validate it really quickly, because once you know the answer, you can easily solve the check to see if the puzzle was solved correctly. And then it's verified, and then the process starts over. So it's this concept of all the computers on the network are validating transactions in kind of a race. They're all trying to do it faster to be able to secure the network. What does that look like really briefly? It's this concept of the previous block, the hash from the previous block is compared with the current, or I shouldn't say compared, but it's put into a hashing algorithm, a SHA-256 hash algorithm, where the previous block, and then the new set of block of transactions, and then this kind of like magic number, the nonce, or this kind of like guessed number, and it's kind of calculated. And the idea is that you're trying to reach a certain kind of difficulty. And if you'll notice on the bottom of this, you'll see there's all these zeros. That is the level of difficulty that it took to get to the answer, to the correct answer. So really, again, it's just that all these computers are kind of competing, and they're kind of trying to guess what this magic number is. And the first person that kind of gets it right by doing all of this kind of proof of work gets rewarded with some kind of reward. So on like a Bitcoin, it's Bitcoin, and Ethereum, it's ETH, and that is your reward for securing the network. So it is important to kind of just know that concept and how the kind of verification works. And Ethereum is eventually going to go off of proof of work. It's kind of on this kind of like roadmap to go away from proof of work and move to proof of stake. But you don't need to know about that right now. It's just good to know at least what proof of work is and kind of how it works. So I talked a little bit about this, but really briefly, you need gas to be able to run transactions on the network. If you heard this term, you're like, what do you mean gas? Like, why do I need gas? Really, it's just the amount of computation. If you look back at that other slide where I talked about opcodes, each opcode requires a certain number of gas to run. And it's kind of like an estimate, like based on this opcode, there's going to be a little bit of gas that needs to be sent in, and the gas is essentially value. So you need to pay up front for your processing power to do something on the Ethereum network. So if you want to add two values together, you have to pay some gas. If you want to, multiply something, you got to pay this much gas. If you want to, there's all these different kind of like rules for how much gas you need to do. But from a high level, it's just good to understand that when you do a transaction, you're sending in not only the transaction and the values from that, but you're also sending in a little bit of gas. And good thing is Scaffold-ETH, again, takes care of this for you and does the base amount of gas. And it will kind of like help you kind of do that for you. So you don't really need to know too much about it, but you have to understand the concept is that everything you do on the blockchain requires a little bit of gas. And it's kind of like the fee to run that kind of computation, right? So that was kind of a real fast run through. We're about 30 minutes in. The next 30 minutes are going to be me actually showing you Scaffold-ETH and kind of what it looks to build like on Scaffold-ETH and how actually quick and easy it is to do. And how really like all that stuff that I just taught you is good to kind of have a basis, but you don't really need to understand that. So really quickly, Scaffold-ETH, it's available on GitHub. So what I do is I encourage you guys all, after you're done with this session, is to go on to GitHub and do a search for Scaffold-ETH and check it out. Look at the documentation. You can go through the steps that I'm going to do today. I'll provide the link to this in the Discord, but it's really easy to get started. So my goal is for you to kind of show you how easy it is to get started, and then you guys go do it yourself and kind of start tinkering. It's built on the concept that you need these three things installed. So you need to have Git installed because you need to check out the repository. You technically could download the package, I guess, from the website, but it's just easier to have Git installed because you might want to like check out a different branch, or you might want to kind of like have multiple branches or something like that. So download Git, make sure you have Git installed, make sure you have Node.js installed because it utilizes JavaScript, and then make sure you have Yarn installed. If anyone's here running Linux, make sure you're using the actual Yarn package manager and not like some like versions of like Ubuntu and like Red Hat come with Yarn, like an old Linux package tool. Don't use that. Use the new Yarn. Just do a search for it and find out how to install that version. But Scaffold-ETH is going to come with Hardhat, which is Hardhat is like it's almost like a virtual blockchain that you can run on your laptop and just kind of get up and running with a basically like a synthesized Ethereum virtual machine that allows you to kind of deploy your contracts locally. And it also has some testing toolkit stuff in it, and it's got some like deploy functionality. So it's really a way for you to like build on Ethereum. It comes with React. So we're going to automatically be able to spin up React, and then it's everything we're going to be doing is based in Solidity. So it has all the compiling tools you need and stuff like that, and kind of all squared away. This is kind of what it's going to look like. We're going to do a checkout. We're going to do a Yarn install. So we're going to check out the repository. We're going to install the prerequisites using Yarn. So Yarn is a package manager, but it also allows you to do like automated commands. So Yarn install is going to basically go out and check out any of the prerequisites and get those installed. We're going to do a Yarn chain to spin up the blockchain. And then we're going to do a Yarn start to spin up React. Then we're going to do a Yarn deploy to actually deploy our smart contract. And Scaffold-ETH comes with like a really basic smart contract that I'm going to show you in a second. It's like a hello world style contract. And then again, as we interact with the application on our Hardhat instance, it's going to automatically build those blocks for you and do all that stuff that happens inside of Ethereum. So if anyone wants to bring up the information on Scaffold-ETH, this is a link to like everything you need to know about Scaffold-ETH. It's like the web page, the GitHub repo, the docs site. There's a Telegram chat if you want to get deeper and kind of talk to any of the developers. So take a picture of this or load this up on your phone and it'll provide you all the links. Okay, so let's do it. So I can minimize this for right now. Minimize this. Okay, so I use a tool called Tmux that allows me to have like multiple terminals up at a time. one option for you guys is just to have different terminals open for different things. But just to explain to you that the reason I have 4 screens here is it's 4 different terminals. And that's because you really, 2 terminals are kind of keep open. The first one here is where I've already gone out and I've checked out Scaffold-ETH. So I've already gone and I did the git checkout, or the git clone, I should say, and I've cloned the repository. I've also gone ahead, let's do a yarn install just to make sure, but I've already done a yarn install and checked to see if there's any packages and installed those. It takes about a minute to do. So I went ahead and did that. Now all I need to do is spin up the blockchain. So I'm gonna do a yarn chain. So literally, I haven't done anything else on this computer except for checked out the repository, did the yarn install, and then I'm doing a yarn chain. And now we have a blockchain up and running on our system. So I'm gonna come over to this other window that I have open. So you guys would wanna open a new window. And then I'm gonna go to yarn start, sorry. So yarn start is essentially going to start up a React server, okay? Listening on port 3000. So let's bring that over here. It's in the wrong window. Sorry, 1 second. Give that a second. Okay, and while that's doing that, it takes about a minute for your React to start up. I'm gonna do a yarn deploy. I talked about it earlier. That's kind of like the final step. And that's what it's gonna do is gonna take my smart contract that's already written and it's gonna push it to the network. So if you look in the top left-hand corner, you'll see that I had some contract interactions. So what happened is my contract was like, okay, or I should say my yarn told Hardhat that, hey, there's a new smart contract. Let's go ahead and deploy it. And it used Hardhat to do that. And then on the top left, you can see that those transactions came through. And then it told me like where my contract was located, like what the address was. And it also told me how much gas that I used. So remember I told you this concept of gas. It told us that we used 393,000 gas to deploy our contract, okay? Now what I'm gonna do is I'm gonna load up my text editor. So I like to use Atom. Any text editor will work. But the concept is that you just want something that's going to be easy. Let me go through this one more time. Close this out. You want something that's going to be easy for you to like kind of see the structure of your directory. And I think most importantly is that you just need something that you're comfortable with editing. And so this is the Scaffold-ETH directory. I want to walk through it real quickly just so you guys can see what all is involved here. But the root directory has the package file for JSON, which basically tells what needs to be yarn installed. So you don't really need to know anything about that. You don't really need to know anything about yarn, just what the commands are. But in the packages folder is where all the components are. So where we're going to be mostly focusing on, and where you'll be focusing on most of the stuff is going to be in the contracts directory. And the contracts is where we have our default smart contract. So this is the contract that comes with Scaffold-ETH. And it's a very basic contract. It has a import, which is the Hardhat console, which allows us to do console logging inside of our browser or inside of Hardhat. And then it also has an event declared, which events are kind of like a way for you to do logging in your contract. And it has a string called building unstoppable apps, which is a really basic string definition. And then we have a function that allows us to update that string. So it allows us to take in a new string, console log that, and then set the new purpose, and then it allows us to emit our event. So again, you can think of events as kind of like logs, or they're kind of a way to do like cheap storage in your smart contract. And so this is a really basic application. So let's see what it looks like. Let's load it up. So this is Scaffold-ETH. So when you first get Scaffold-ETH up and running, this is the kind of like overall UI. And what you'll notice is that you have this like kind of like idea of a wallet. It's called a burner wallet that's built into the user interface. So right here, we have a wallet that has no funds. I could connect my MetaMask wallet if I wanted to, or I could connect like a Rainbow wallet or some other wallet that I have. But the cool thing about Scaffold-ETH is it has wallets built into the UI and that run inside the browser. You don't really need to use anything. You don't need to use MetaMask or anything like that. So it's got this idea, so I can say, just let's get some funds from the faucet. And what it does is it uses Hardhat, which has some predefined kind of fake money, and it allows me to pull that money out into my burner wallet. So now I got some funds in my burner wallet. And if I wanted to, I could take more funds out. Like I could grab my address, like here's my address for the burner wallet. And I could come down here and I could get more. Like I could say, well, I actually want to get like, I don't know, $100 and hit send. And I could send myself $100 from the faucet. So it allows you to kind of act as like, in this kind of like testing environment where you can pretend like you're a whale or something like that. So if I wanted to, like, I don't know, I could send, let's try to send like, I don't know, another $10,000. Cool, so I'm rich now. You get the idea. So now when you first log in, you have those burner wallets, you have the gas station down there where you can like see how much the gas is gonna cost at this current time. If you were on production, which we're not, we're just using hard hat. So everything is kind of real basic here. It tells you the price of Ethereum and it tells you how to get support. But this first tab you'll see is like the app home. This is where you would like build your app out. So as you guys start to learn Solidity and you get comfortable with that, then you might want to start building out your UI. And this is where you'd want to do that. That is inside of the React folder. So in here, there's a React folder and you have your source directory and you have the app.jsx file, which is this kind of like Scaffold-ETH app that you're looking at. But then inside of the, I think it's under views. Yeah, you have the home folder, which is like your home application. So you could start building your UI in here. We're not gonna do that right now. We're not even gonna focus anything on React. So we're just gonna close all this, but I wanted to show you it's there. But the most important thing is this debug contracts tab. And what this is gonna give you is out of the box, it's gonna take your smart contract that you've already deployed, which is the basic one. It's gonna give you all of the variables from it. It's going to give you all the functions, and it's going to automatically inject the contract address and all of the functionality for you to build on Ethereum, or I should say test what you're building on Ethereum inside of React. So you don't need to know React because it's just going to do it for you. So if I want to come in here now and I want to say, well, I want to set a new purpose. I'm going to say Growic is awesome, like this, and hit send. So what I'm doing right now is I'm using some of my money to pay gas on a hard hat to update the purpose, which is exactly what the smart contract wants to allow us to do. So that's cool. I can actually update the thing. And you can actually have this other concept where maybe you have, let's do a new incognito window and let's go to localhost 3000. Oops, sorry. And then you can have like two wallets open. So this is another burner wallet. I could get some funds for this one. And I could go to debug contracts and then I want to say something else like Kevin is awesome or something like that. Right? So you can have this kind of like testing pattern where you can like test stuff between two browsers and two wallets. So because you have these like burner wallets, this one, you can even send money back and forth or whatever you want to do. So let's just keep that kind of like that incognito window open. Hints, example UI, you won't get to this till later, but it's just some examples of how you might build the UI. And then you have this subgraph folder, which also we probably won't get to, but it's how you would like build a subgraph API. So really everything you're going to be doing for a long time is just in this debug contracts folder. Okay, so let's do some tinkering. Let's start changing some stuff. So let's go back to our contract here, right? And let's try to change some things. So the first thing I want to show you is that the first thing you learn in Solidity is this concept of like require. So you can have like a function and you can have the function do a specific like kind of requirement. It's like a check. So I can say, all right, well, let's require that, well, first of all, let's set a new variable. Let's do an address variable. Let's make it publicly available and let's call it owner. And let's set it to a specific string. So let's grab this contract address, or I should say this wallet address, and let's paste it in here. And let's save that. And then let's go over here and let's say that this set purpose, we wanted to make it sure that only the owner was allowed to, I don't know, change the purpose, right? So we might do something like message, require that the message.sender is equal to owner. And if it's not, then let's say you are not the owner, like that. And let's close that off and let's save it. Now let's go back to our terminal here and let's go ahead and redeploy. So let's do yarn deploy. So we've made some changes to our smart contract. We're going to redeploy those. We don't need to mess with hard hat. We don't need to mess with React because those just stay open. And we can see that it was successful. And we can see our contract calls in the top left. Now we can go back and we can see that we have this new variable and it matches the address here. So now we have a owner. And if I come over here on this rogue kind of instance here and I try to change the purpose to like Kevin is awesome, exclamation mark, and hit send, I'm going to get an error. You're not the owner. But if I come over here and I say, no, actually, Growic is awesome. I spelled it wrong, but that's okay. You get the idea. Boom, it let me do it because this is the owner account, and I've done this kind of like check. It's like a require statement. But that's not very cool because like, why would you have like a function that only you could call? Like, it's kind of silly. So let's actually get rid of that. Oh, actually, let's do it a little differently. Let's just say that we're not going to do it this way. We're not going to do a require statement. Instead, we're going to do what's called inheritance. So Solidity has this ability to do importing. So you can import some existing contracts or maybe an alternate contract that you have. And there's this whole slew of contracts called Open Zeppelin. And if you haven't heard of them, but they're basically they're a company that kind of creates these like secure, solid, function efficient contracts that have everything you need to get started. And one of those is called ownable. So we're going to inherit this ownable contract by referencing the Open Zeppelin contracts. And there's a specific subset of those contracts called access. And we're going to set that up. And then what we're going to do is we're going to say your contract is actually ownable. So it's not only the contract you're writing, but it's also inherited from ownable. And then what we can do is come over here to this function and say only owner. So only the owner. So it's kind of like the correct way to do access control of your smart contract. So we could save that. Let's deploy it again. So it's just kind of like looping idea where you're like prototyping your contract, you're deploying your contract. We got it seems like it worked. So let's come here. So now we can see that the owner, well, there's a problem here. The owner is not the address that we would expect because it's not the one that we hard coded earlier. Well, what is this address here? So it's important to understand that Hardhat has I told you earlier, it has a set of accounts that come with it. And they're like, there's one particular deployer contract or deployer account, and it's the first one. And so when your contract is deployed using this yarn deploy command, it actually utilizes this deployer contract. So what we need to do is we need to transfer the ownership, because if you'll see here, now we have this new function here called transfer ownership, which allows us to transfer the owner of the smart contract, because the smart contract does need an owner. It can't completely live on the Ethereum blockchain unless you revoke the ownership, which you can do. And you'll see that dApps, that's what they do to increase their reputation. They'll deploy a smart contract as a specific owner, and then they'll build a function that allows you to revoke ownership to make sure that it is truly immutable. So what we need to do is we need to transfer the owner to this address, actually. So how do we do that? Well, there's a special folder for that, and it's right here in deploy, right below the smart contracts folder. And you'll notice that this is the deploy script for deploying your smart contract. So right now it's using the local host, and it's using ethers and Hardhat. And you'll see right here that a variable is being created, and this variable is like an instance of your contract. So this is actually your contract getting deployed using ethers. I talked about ethers.js. It's basically a way to deploy and like interact with your smart contract using JavaScript, but there's also a functionality for ethers as well. So you'll see that there's this concept of deploying your contract using transfer of ownership. So right here below, so let's do that. Let's go ahead and just transfer the ownership. So we actually need to do transfer ownership of your contract, and we need to grab the address again. Oh, and you need to actually wrap it in quotes here. So like that. So we've said, okay, we already have an instance of our contract. Now let's call this function inside of the smart contract called transfer ownership, which is like a set. This is a set function of ownable, which we inherited. So you can see how we're kind of start to being able to build on our smart contract. So we've done the transfer ownership. We've specified the new variable. Now let's deploy it. And right now, you guys don't need to, I'm going to give you guys all the steps for this so you can replicate this stuff afterwards. So don't feel like, oh, I'm lost. That's okay. It's just, I'm just showing you kind of how we tinker and kind of how we build on Ethereum or on Scaffold-ETH. So now it's deployed. Let's check out the app one more time. I might need to refresh because I did a weird deploy. Okay, cool, it worked. So now we can see that the owner variable matches my address here. So it's matched right here. You can tell by just looking at the last 4 digits. Okay, so that now we have ownership rights of the contract. So we've gone in, we've set this functionality. But again, let's extract this concept of ownership on this function, and let's get rid of it. Instead, let's do something a little bit. We can still use the inheritance. We can still use this here, and we can still make it an ownable contract, and we can have access to it. But let's just change this set purpose function to do something actually a little more cooler. So what I'd like to do is instead let anyone use this function, but instead let's say that we want to require that they deposit some money every time that they use it. So I will say message.value is equal to 0.001 ether, or send me more money. All right. So this concept here is that we're doing a check, like I told you before, we're doing a require statement, and we're requiring that anyone who interacts with this function actually has to send 0.001 ether. Otherwise, they're going to get an error that says send more money. Okay, so what is this going to allow you to do? It's allow you to start using your contract as a bank. So let's deploy that. And let's refresh. Let's make sure. Oh, I did some kind of error. Let's see. So I said, oh, I need to, so the function has to be payable. So this is a public function, but we actually need to make it payable so that it can receive money. Okay, so let's do that. Let's deploy again. I always make that mistake. So anytime your function is going to accept money, it's got to be payable. So now we got this new function. Actually, we have the same function, but you'll see there's a new section for it, and that's the value function. Okay. So now if I want to change the function, I could say like, Growic is awesome this time, but if I try to send it, it's going to say send more money because it doesn't have any money attached to it. So I didn't get too much into this, but we talked about gas, and we talked about kind of like this idea of sending in gas. But what happens when you want to send in transaction value? Well, you do so with ether. But you actually are transacting in a very, very slow, like low kind of like division of that called way. So the concept is that if you want to interact with your contract, you actually need to send in the amount of the smallest divisible amount, which is called way, which is 10 to the 18th power. Okay, so there's this little function here, this little green icon here that does that, which allows you to just put in like ether. So I could, what do we say, 0.001, right, ether, and I can click this little green button, and it's going to multiply that times 10 to the 18th power for me and tell me exactly how much way that I need to send in. So it's very good to understand that, for a developer experience, like if you wanted someone to use your app and you wanted to charge them 0.001 ether every time, you wouldn't have them type in 1.00000 way, right? You would tell them in ether, and your app would need to make that kind of like translation itself. So this is just to show you what that would look like when you need to do that, because everything you transact in actually is in way. But the ethers JS library has this functionality that allows you to talk with the shorthand of ether. So you could define it either way. So now we should be able to send that, and it worked. So it allowed me to change the function to Growic is awesome. And you'll see here that I now have some money in the contract. Now there's $1.86 inside the contract because it cost me money to update the purpose. So if I wanted to, I could come over here and I could try to do it. Same thing, I could do 0.001 and then translate it and then add it. So now we got $3.71. So the contract starts acting as a bank. But there's a problem. We didn't create any function to be able to remove the money. So the money is literally kind of like trapped in there. So the next feasible thing would be to make a withdraw function, right? So let's do that. Again, you guys can see how we're kind of building on top of our contract here. So we're going to do a function, and we're going to do withdraw. And we're going to do a full, we're just going to make a function that's publicly available. And what we're going to do though is make it only the owner. So remember we did this inheritance concept, right? So only the owner can withdraw the money. And then what we're going to do is just going to do we're going to set a Boolean called success if the extraction was correct, or if I should say the removal was correct. And we're going to basically send all the money to the message.sender. So we talked about message. So there's message.sender, there's message.value. Message is basically some built-in global variables that are available in the message when you try to interact with the smart contract. So message sender is literally the person that's actually sending the request or the transaction. So we're going to do what's called a call, which is a call value. So it's going to say like, well, I want to transfer money. A call is like anytime you want to pull money out of a contract or out of a smart contract, you use call. And we're going to make the call reference the address of this smart contract, right? Oh, actually, it's wrong. It needs to be this and dot balance. So we're going to check the balance of this smart contract, and we're going to just grab all of it, basically. We're just going to like rug pull this contract. And then we don't need to say anything else. That's it. So we're going to create this withdraw function, set a Boolean just so that the function doesn't fail. And then we're going to withdraw the balance of the contract to the person who sends the request, but they need to be the owner, right? Because it's only owner. Let's save that and let's deploy. What did I do wrong? Probably did something wrong. Address. Make sure I spelled everything right. Function withdraw, public owner, bool success. Oh, that's what it is. There's extra dot. Sorry. So the cool thing is, like I said, you get these kind of like things in your terminal, and you can kind of like troubleshoot and figure out what's going on. Okay, it worked. So it deployed. So now let's do a change again. So we have some money here. Let's set the purpose to yo, what's up? All right. And let's do 0.001 Ether and let's update it. Okay, it worked. Now let's go over here. Let's do it again. Kevin is cool. Send. So now we got $3 in there. So if I wanted to come over, let's say I was this kind of like bad actor. I was in this like incognito mode and I saw, oh, there's a smart contract here. I want to get the money from it. Well, there's this new function down here. You can't see, but sorry, 1 second. It's right here. It's called withdraw. If I click send, it's going to give me an error because I'm not the contract owner, right? So because it's only owner, right? So now I can come over here and I'm the owner for sure on this one. I can withdraw, and there we go. I just pulled the money out of the account and it went back into my wallet here. So you can see how you can kind of make these kind of like cool, kind of like vending machines in the sky where you can kind of like interact with that smart contract. Okay, so I think, let's see what else you might want to do. I mean, there's other stuff you could do, but let me kind of go through everything one more time because we got about 5 minutes. So I want to kind of like reiterate kind of everything with you guys. So when you get going and you get back to your own kind of time and you want to start practicing and kind of learning how Scaffold-ETH works, you're going to need to spin up a few terminals. You're going to need to have Git. So you're going to install Git and you're going to check out the directory. Once you have the directory checked out, you're going to go into that directory, do a yarn install. All the package requirements will be easily installed just by running that. After that, do a yarn chain. We'll spin up your blockchain, open up another terminal, do yarn start, and then let that one sit as well. That's what we see I have in the right-hand corner here. And then on this kind of like third terminal is where you kind of do your tinkering, and that's where you'll start doing your deploys. There also is a command called yarn watch, which is kind of useful. I sometimes use it. What yarn watch will do is it will constantly watch the smart contract for you, and it will try, I got an error. I don't know why. Sometimes it gives me an error, so I don't always use it, but it will kind of like watch your smart contract to see if you've made changes and automatically to deploy it. So you can use that, but yarn deploy is just a manual thing that you have to do, right? Oh, okay, I'm getting some kind of error, so I don't know why I'm getting an error. I think at some point, this is a good thing to know. If you want to reset your network and reset your kind of everything, you can do a yarn deploy -- network -reset, I think. Yeah, I think that's the right one. Oh no, maybe it's -- reset one. Yeah, there we go. So if you start getting any weird errors or something like that, you can do a yarn deploy -- reset. So that's kind of just a way for you to like fall back and kind of go back from the start. And so it's going to keep all your changes in your contract, so you don't have to worry about losing that stuff. But what you will have to worry about is like, it will kind of reset the smart contract, and it will reset. Oh, it doesn't reset your burner wallets though, so it does keep that funds as well, I believe. So it's really just going to reset your smart contract and kind of like your chain. So if you made any change to your smart contract, they'll still be there. But any changes on the network that you've made, like updating the purpose or changing the owner or something like that, might get kind of like switched around. Okay, so we're almost out of time. So I do want to allow people to ask questions and stay on if you guys want. Don't feel like you need to hop off. I'm going to hang out for at least like 30 minutes or so. And I'll keep an eye on the Discord as well. But it is kind of late for me. It's 5, so I probably hang out till like 5:30. But if you guys have questions over the next like few days or week or whatever, I'll still be in there. And let's look at the questions that we might have in chat. Let's see. We got some hellos. Nice to meet everyone. Hopefully everyone got the Discord. It's in the chat if you guys don't have it. It is recorded, so we'll send that. So okay, that's a good question. What is the assignment for this week? So you guys are probably wondering, like, what should you do now? So there's not like a set. What I'm going to do is I'm going to share in the channel pretty much all the steps that I just went through and some more. So what I'd love for you guys to do is to go through those steps. And actually, let me do that right now while I'm on this kind of like thing. So let's go to Discord and I don't know why my Discord's not working. There we go. Okay. So this is a Bitbucket. So everyone should be able to click on that. And what it is it's basically kind of everything I did. I did it for another conference. It's called Hack Money. So if you guys want to watch the replay, you can also watch, and this replay is going to be shared with you. But it's all the steps you need to do. So if you scroll down, there's the Scaffold-ETH setup, which is like all the stuff, yarn, chain, yarn start, But then there's also the concepts of what I did. I showed the file structure. I showed how the burner wallets work. But then this is the actual changes that you're going to make. So this is the variable and require statement for message.sender that shows you how we change the owner. But then it also showed you how you do it with like inheritance, with the import command, and then you define the ownable. So I'd like you guys to try to replicate what I did, at least all the way down to what I did. But then I also have some additional things here, which is like creating a modifier where you might like modify the price using a modifier. So I'd like you to go through this stuff. Also, there's a website called Solidity by Example. What I just want you guys to do is just get comfortable with Scaffold-ETH. And the best way to do that is actually to go through Solidity by Example and like copy and paste stuff in there and deploy it and kind of see if it breaks. And if it does break, then figure out why it's broken, Google it, or try changing it around, or do these different things. There's all these little concepts, and this is a lot of the stuff that what you're going to be going over the coming weeks. So if you kind of like go through this a little bit, then you'll feel really comfortable in the next sessions that come. Okay. What other questions we got? So the question is, Scaffold-ETH is very similar to Remix. It is very similar to Remix. Personally, like Remix doesn't have any kind of like UI related stuff. And it also utilizes, it's a cloud instance version of kind of like Ethereum virtual machine where it's like running in your browser. I personally think that if you're going to learn, this is a better hands-on approach because you're actually creating a local development environment and you're kind of getting a little bit more into how you would actually really deploy your application. Like most people wouldn't deploy their application through Remix. They might just use Remix to like tinker with like Solidity code and like see how it runs. But I think really like, I'm not to say you couldn't with Remix. When it comes down to it, you want to have more of like a development environment set up for deploying. Yeah, so I'm going to share, I shared the link in the Discord channel. Any other questions? Does anyone want to come off mute and ask questions at all? Or just give some feedback? That would be great. We definitely, like I said, we want to hear feedback and see if it was enough, if it was too much, too fast. I tried to kind of give you this, again, this is not designed to kind of like teach you everything you need to know. It's really just to kind of get your feet wet and kind of get going. yeah, let me paste it here. So those are the kind of the steps. Yeah. Oh, thanks. Someone else got it. I believe the next meeting is. It's a good question. I believe it's next week. Yeah. Or maybe it's end of this week. Hold on. Let me look. One sec. Okay. So according to what I saw, it looks like June 13th. So actually, it might not be till next week. But yeah, double check in the Discord channel just to make sure that maybe I don't have like an out-of-date version of that. Let me just make sure. I have one other thing here I can check. Okay, sorry, June 9th. Yeah, so it looks like June 9th is going to be primitive data types. So if you guys want to kind of get your hands on that early, then that's all in the Solidity by example. So I talked about that as well. So there's a primitive data type section. So if you guys want to get a little familiar with it, kind of toy around with the primitive data types and how they work inside of Scaffold-ETH and kind of try deploying and adding these. And we're just going to go over all like booleans, uints, ints, addresses, what those are and stuff like that. So. Oh, cool. Thank you. All right, cool. Yeah, any other questions that you guys have?
Hey, Kevin, I just want to say this is a good good introduction, and thanks for going through this. I think I got most of it working, just observing you. So it's not. I don't think you went too fast. I think it's probably going to take us some time to just go through the Solidity by example stuff to really wrap our minds around all of this stuff. But it's a good start.
Cool. That's good. That's good to hear. Yeah, I appreciate the feedback. Yeah, because I wasn't sure, you know, like the experience that people have with like tooling and you know, command line and stuff like that. So hopefully, if you guys do have problems, again, the Discord channel is going to be a good spot. I have a question. Yeah, so VM exception while pressing transaction reverted. So are you getting that inside of the Scaffold-ETH when you're trying to run it, or are you getting that in the terminal?
I'm getting it in the terminal when I'm trying to deploy.
Okay.
I put it on the Discord with more information, if that helps.
Yeah, that might help.
I've never seen that. I don't know what it means.
Yeah. So it seems to me like in exceptional processing transaction. How are you?
Oh, it's using the payable needs to go before public. I think that was what Kevin was doing earlier in the function declaration.
Yeah,
oh, payable. Yeah, did you make it payable?
I tried both ways just to see, but it still has the same error.
Oh, do you have a semicolon or? Oh no, that's right.
Yeah, I do. In the notes you provided, you put payable after public, so that's why I changed it.
Let me just try it real quick on mine and see. I'm just copying and pasting your whole function here. It actually deployed for me, so I'm thinking it's something else. Do you have any other weird like characters that maybe you accidentally added, or maybe you didn't? Like maybe you didn't complete one of the lines.
Yeah, hey, Stan, do you want to share your screen, maybe?
Yeah, you could. I don't know if I need to give. I might have to give you rights to share your screen. Let me try.
I mean, I put it on Discord also.
Yeah, I see it. Yeah, but can you paste the whole contract? Oh, you did.
Yeah.
Let me double check real quick.
Yeah. Thanks for the help.
Oh, of course. That's exactly why I'm here. So. Yeah, that entire code is working for me. So I'm wondering what it could be. Did you update the any other files like the smart contract deployment file, like the deploy your contract.js?
Yeah, I added your contract line.
Can you paste that whole file in Discord?
Sure. Maybe I put the wrong address.
No, that shouldn't matter. Just if it wouldn't let you, like, it would transfer the ownership to like some random thing. Let me try to deploy that. Okay, there we go. So now that errored for me. Let's see what we got here. Oh, okay. I think I know. No, that's right. Oh, you uncommented that. Oh, okay, so I think you had the you were trying to update the purpose before you transferred the ownership, and you were using ownable. So you basically had this kind of chicken before the egg problem. So the line that says await your contract at set purpose hello, you had like gone in there and you had like tried to set the purpose, and you have the only ownable in there, so then it probably must not let you for some reason. Oh, because you're not sending value, that's why. Because you're trying to update the purpose without sending value. So your deploy script is basically like being blocked because you're not sending any value. Does that make sense?
So the value is the money, right?
Yeah. So like the change that you made on the smart contract was that you require that the message value contains a little bit of ether, right? So that line on line 30 that says your contract.set purpose hello is going to fail because you're not sending the ether. So that's kind of why.
Oh, okay.
You get it? Yeah.
Yeah. Okay. Yeah. I think
so just take that out. Yeah.
Accidentally uncommented it, and I didn't realize.
Yeah, that's fine.
And the error isn't very descriptive.
Yeah.
Thank you. I appreciate it.
Yeah, no worries. Yeah. All right, cool. Any other questions for you guys, or other than the the content that we have planned? Was there anything about Ethereum or blockchain or stuff that we didn't answer that you're trying to learn? Or does anyone have any other feedback? Okay, cool. Well, it was nice meeting all you guys, and I look forward to seeing you guys around. I'll be around for some of the mentorship sessions. I'll stay on Discord. I'll try to keep an eye on the chat, and happy to help you guys in the future. Okay, guys? Later, guys.